All right, let's wait a bit. So for people to join me, let's wait for a minute. So yeah, I'm waiting for a minute before I formally launch this webinar, just for people to join in. And thank you everyone to join this webinar. And good morning, good afternoon, good evening for everyone here. So yes, okay. All right, so with people start to joining, I'm going to, let me introduce myself. So hello everyone, I'm the host and presenter today. I'm from ORCID, I'm Estelle Chen. Now I'm the ORCID Engagement Manager for Global Direct Members and also service providers, in particular for the APAC region. So it's very a great pleasure to invite speakers today and to share a bit more about, anyway. Oh, you can hear me? Someone cannot hear me, is it? Can everybody let me know if you can hear me or not? So, no? Can everybody hear me? Okay. Okay, I'm going to just keep going. Oh, that's fine. Okay, perfect. Thank you. I'm just, all right. So thank you. Yeah, I'm a bit kind of nervous in a way to operate this. So yeah, I'm going to start to play a short video about the housekeeping roles. So let me do this now. Let me start sharing my screen. All right, okay, just let me double check. Everything okay? All right, so audio is fine, okay. Okay, right. Yeah, so let's keep continuing. And today I'm happy to also have my colleague, Nabil Kispi, who is based in South Africa, to support this webinar. And now I am going to start actually from introducing today's speakers as a starting point. So I already introduced myself, and today I'm very happy to have another 3 speakers joining. So let me invite Dr. Tiffany later on to say hi, but let me just briefly introduce Dr. Tiffany, who is based in Canada now, so it's very late. Thank her for her participation. So I will, she will be around, but her presentation is pre-recorded, so I will play the video. So yeah, let me start by introducing Dr. Tiffany. Dr. Tiffany Straza is an open science consultant in the section of science, technology, and innovation policy at UNESCO. A marine scientist by training, she holds a PhD in oceanography, University of Delaware, USA, with a specialization in marine microbioecology. She served as deputy editor and statistician for the UNESCO Science Report 2021. Since 2022, she has been supporting the implementation of UNESCO Recommendation on Open Science. So Dr. Tiffany, I will invite you to briefly say hi. Dr. Tiffany, can you do this? Can you say hi to the audience? No? Well, I'm here. It won't let me speak. Oh, really? Let me just check. So, okay. Let me just to share that. Okay, let me just check. Sorry, a bit technical issues. Let me just check. So can you speak all the speakers? Let me just check. Speaker icon. I need to. Speaker icon. Oh, I'm so sorry. Sorry, everyone. Speaker icon. Where's the speaker icon? Let me just check. Sorry, everyone. Let me figure it out. Where's the speaker icon? Speaker, where's the speaker? Give me a second, everyone. Apologize. I need to. Let me give me everyone. So let me just after live webinar feed. Oh my God, where's the speaker icon? On air? No? Oh, sorry, everyone. I need to spend a few minutes to figure out how to invite everyone joining. That's a bit. Let me just do it. So let me just check. Okay. Is it okay now? No? Still no? Oh, I'm so sorry. I need to figure out how to start it. So is it okay now? No? I don't think it mutes everything. I don't know how to do that backstage. Okay.
I think we've sorted out the technical issues.
Yes, thank you everyone for your patience with figure out. Yeah, hello, Dr. Tiffany, please say hi to everyone.
So yes, just to say a quick hello and thank you to everyone for your time today, including for your patience with us as we sort out these technical challenges. We were just talking backstage. We're very excited to have this discussion about persistent identifiers because this is a new topic for a lot of us within open science. So looking forward to today's discussion. Thank you.
Thank you, everyone. Oh, okay, I'm the second speaker, so I'm skip myself. I already introduced myself. And next speaker, the third speaker will be Martin Whitman from Crossref. So I'm going to also introduce Martin now. So Martin joined Crossref in June 2020 as product manager. So Martin, you need to mute yourself for now. I will hear my echo. Okay, anyway, so prior to that, Martin spent 7 years at Open Access Publisher MDPI in various roles, including production, editorial, and author services. And before moving into publishing, Martin was a researcher developing instrumentation in life science, material science, and analytical chemistry. He completed his PhD at the University of Warwick before postdoc positions at the University of Leiden and the University of Freiburg. Hello, Martin. Nice to see you, and please say hi.
Yeah, hi. Yeah, really nice to be here, and looking forward to presenting and also hearing from the other speakers today. So yeah, nice to see everybody.
And can everyone use chat now? Let me just double check. No, I think everyone can just enable it. So, okay, perfect. Yes. Oh, okay. The fourth speaker will be Xiaoli. So I'm going to invite Xiaoli. So Xiaoli Chen is from DataCite, and she leads the Implementing Fair Workflows project, working on building exemplar fair practices throughout the research life cycle with the project team and partners. She is also responsible for the outreach effort in the APAC region while co-chairing the DataCite APAC expert group. She holds an MLIS from Zurich University and is working towards her PhD in the same fields from the University of Sheffield. Hello, Xiaoli.
Hi Estelle, hi everyone. Really happy to be in yet another edition of the Better Together webinar with everybody in the APAC region. Yeah, like looking forward to the talks and discussion.
Perfect. I'm glad that looks like all the technical issues solved out. That's a relief. So before we start, the first speaker will be Dr. Tiffany. So I will play her recorded video. As I say, it's very late for her, so we decide that it's best to play her the video first. But before that, I'm going to conduct a mini poll to collect everyone's feedback. So let me do it now. And yeah, you should be able to see the pool. So please take a few seconds to do it. Can you see the pool? I hope so. No? Okay. Then no one is answering the pool. Is it working now? Okay, it's working now. Perfect. Thank you, everyone. I'm just, again, a bit intimidated by the initial technical challenges. I'm happy now it worked. I'm going to wait another 10 seconds. All right, last 30 seconds. All right, great. I think most of you already complete the poll, so I'm going to stop polling now. Probably another 5 seconds. I think people still vote now. Okay, great. Let me stop now and share the results. I hope everyone can. Yeah, it's good. I think the majority of attendees today hear about UNESCO Recommendation on Open Science. And we will have Tiffany to explain a bit more in detail. And also about around more than 50% attendees, your institution adopt somehow policy, which is also good. We want to learn more, and also good to see everybody's feedback on your ideas or perception on open science, and which, of course, the topic today. All right, so I'm going to stop sharing. And finally, I'm going to just start with today's Dr. Tiffany's presentation. So it's a recorded one, so let me do it now. I'm going to stop sharing screen. So let me give me a second. Okay, it's working. Okay, so sorry, give me another second. Okay.
Thank you so much. Thank you to our hosts, and thank you to each of you who are listening in for sharing your time with us today. I think it's valuable to explore why open science is a global project and what that means then when we consider the development of new tools or practices, including persistent identifiers. So today I'll introduce the global framework on open science, share why we believe an open and equitable approach to science is the best way forward, and then link this to the work on persistent identifiers or PIDs, and show what we've identified in terms of action areas and ways to engage in the coming months. I want to start with a reminder of what countries have agreed on in terms of what open science is and what our priority actions need to be to undertake a transition from science as usual to a science that is more open with more knowledge sharing, but also a science that is more equitable and transparent, that serves all of society, both scientific practitioners and the users of science. We can think of this in the context of the Sustainable Development Goals, which are aiming for a better world for all of humanity. And we can also link it right back to the 1948 Universal Declaration of Human Rights, which states that all people have a right to participate in science and its benefits. Closed scientific practices amplify inequalities among people and among countries. Even though the majority of scientific research is paid for by governments and with public money from taxpayers, the practices and the results of that science are commonly closed off. We know that science is produced and paid for unevenly around the world. The G20 countries account for 9/10 of research spending, 9/10 of researchers, of publications, and of patents. You can find more information about those statistics in the UNESCO Science Report, which most recently came out in its 2021 edition. We also know that the tools and infrastructures that are used to conduct research are similarly unevenly distributed. So change is needed, and there has been a groundswell of action towards open science by many different people in many different ways around the world. But not everyone understands the same thing by open science. But if we agree on what we mean by open science, we can create a more coordinated approach and therefore a faster and stronger effort towards multiple dimensions of open science. And that's why UNESCO, which is the United Nations organization that has the mandate for science, led a consultation process starting in 2019 that was regionally balanced, that was inclusive and transparent as possible to help us develop a shared approach to open science. And so 2 years ago now, 193 countries adopted the UNESCO Recommendation on Open Science, which is the first global standard-setting instrument on open science. For those who might be new to UN recommendations, a recommendation is a legal instrument. It's not legally binding, but it is a negotiated text that sets out shared principles and shared norms. Countries commit to these, and they also commit to a regular reporting process. So what this means for us is that every 4 years now, countries are going to be checking in to show what they have done to make science more open. At UNESCO, we're developing a standardized survey and way of assessing this progress. For example, there will be a national member state survey that will be adopted in 2024. So with the adoption of this recommendation, we have now hundreds of countries that have committed to promoting and enabling a policy environment, to investing in infrastructure for open science, for capacity building for open science, and have also committed to aligning incentives and promoting innovation and cooperation to foster open science. I won't read through each piece of these slides. I do want to reassure you that the slides will be shared and they are available in multiple languages. I want to point out, though, that the recommendation identifies multiple actors and stakeholders in open science. We know that we need to go beyond just the conventional scientific community. We all have a role to play in terms of turning open science into action. So we now have a shared definition, a normative framework, and a common roadmap for action. As defined in the recommendation, open science does make scientific knowledge openly available and accessible and reusable for everyone. But that's only part of open science. Open science is also about increasing collaborations and increasing the information sharing for the benefits of multiple people. Open science is about opening the processes of knowledge creation, of evaluation, and communication. And we see efforts across these 4 key pillars of openness: open knowledge, open science infrastructures, which includes both digital and physical infrastructures, open engagement of societal actors, as well as open dialogue across knowledge systems. In other words, we're talking about openness in knowledge production as well as in knowledge dissemination. Open science is about increasing openness throughout the entire research cycle. And it's not just about openly sharing the end products of scientific research or sharing a single piece of technology. What that means then is that when we're talking about equity in science, we're talking about equity and participation throughout. So with the recommendation on open science, countries also defined a shared set of principles and values. Today, I want to specifically note that equity, fairness, and inclusiveness are among these. It's been made clear that the kind of open science that we want is one in which there is equality of opportunities. So how can we turn this into reality? Member states have been encouraged to prioritize 7 areas of action in their implementation of the recommendation on open science. And the 7 action areas that you see here are shaping our work within UNESCO and at the country level. I want to highlight today that there is a recognized aim of investing in infrastructure and in services that contribute to open science, as well as there's an effort for promoting international and multi-stakeholder cooperation, including with a view to reduce the existing digital, technological, and knowledge gaps. And why would we do this? We do this because open science isn't really functional if only a few benefit. You can think of this in the same way that infrastructures and shared practices are most functional if you have many, many different people using them. For open science to reach its full potential, it has to be, therefore, truly global and an equitable phenomenon. To put it another way, until it is open to all, and until it actually reduces those existing inequalities in science, technology, and innovation systems, open science would have failed. But not all countries and not all open science actors are starting from the same starting point on their journey to open science. We know that context matters. Context affects how we experience open science in practice. It also affects how we prioritize open science as a whole or the different elements or practices within open science. Lack of equity in access to skills and tools is a barrier to participating in science in general, but it's also a potential barrier for participating in open science as it is currently practiced. In this meeting, we're focused on persistent identifiers and technologies, and it's clear that the capacity to create, to use, or benefit from these systems and these technologies is not the same for all. I think it's also important to keep in mind that open science has had some unintended negative consequences as we selected different practices. And we need to pay attention to where we might be increasing the resource burdens on those who wish to participate, or perhaps increasing the vulnerability of those who share their knowledge. So when we consider open science, I think we should ask, open by whom, for whom, to whom, and for what? When I say open by whom, I mean who decides what is shared, who decides how it is shared, and what people are permitted to do with the shared material. There have been significant advances in the legal frameworks and the technological frameworks that support authors and creators to choose and to make publicly known their choices about their own works when they share. But I think we still have work to do in terms of cultural change and in terms of the governance of the systems and infrastructures that are used for open science. From an equity standpoint, we need to ask ourselves some questions here about what it actually takes to open science, to share data or to share knowledge. For example, if it is the responsibility of the researcher themselves to create open access to their knowledge, do they have the tools and infrastructures to do so? Can they actually implement something like a persistent identifier system? Do they have the skills and capacity? Do they have the confidence and security in their intellectual property rights? And do they face the same consequences as their peers in other countries or contexts when they choose a particular pathway towards openness. By open for whom, let's remember here that the answer here does not have to be for everyone in every case. The recommendation on open science itself notes certain instances where it might not be appropriate to have uncontrolled open sharing of all data. We can think of the case of sacred and secret indigenous knowledge, or where sharing data about a particular animal species might place a threatened species at greater risk. But there are also ways to share information about information and to open knowledge to those in greatest need. And in fact, open doesn't not automatically mean open to all. We all know that having something be available on the internet somewhere does not mean fully open. I think we need to also ask, who is actually the audience for openly shared materials? Who is the intended audience, and who is really accessing them? Who can access them? Who has the internet, the time, the language, the capacity to access, to use and reuse shared materials? And we need information to be able to answer that question, which means we need a way not only of reaching more people, but also of identifying who is using materials or where materials are going throughout a scholarly system. In efforts here, of course, we can think about the fair, care, and trust principles. For today's session, I'm sure that the elements of fair, the findable, accessible, interoperable, and reusable are very important. But we should also consider here collective benefit, authority to control, responsibility, and ethics within the care principles, or elements of things like sustainability and technology within the trust principles for digital preservation. And finally, open for what here? Open does not necessarily mean rights free or without rights. Rather, open sharing allows me to identify the creator and to identify what they permit to be done with their shared knowledge. The vision here is of effective reuse, but the continuing need is for credit, for contributions. This has moral implications, but also has significant ties with how we assess individuals and institutions, and sometimes even countries, with reference to their impact, which has implications for career progression or even for retention in the scientific field. When we build systems to share knowledge, we need to address the need to build systems that allow us to identify and measure impact, to identify where knowledge is coming from and how it is spreading throughout science, for what purposes it's being reused, and so on. So what does any of this have to do with persistent identifiers? I think these ideas of equity mean that we have to consider the balance between new cost and skill and time barriers and the benefits of expanded access and interoperability. Open science is not just about investing in new tools. We need to carefully consider what is possible and what is most functional to take advantage of the benefits of open science practices without creating additional barriers. So I want to mention here a particular piece of guidance that we developed. We have open science working groups. I'm going to talk about those a little bit later. They're wonderful groups. We have over 700 people from all geographic regions. And they've helped us to prepare this open science toolkit, which is a set of guiding documents, a set of online indices, and so on. But I want to draw your attention today to the guidance that we have developed on open science infrastructures. We know that open science requires and merits systematic and strategic long-term investment in science, technology, and innovation systems in general, but with an emphasis on investment in technical and digital infrastructures and their related services. We know that investment should consider the long-term maintenance of such infrastructures and how they can be used to preserve scientific knowledge and make it more usable into the future. And when I speak about investments here, I mean both financial resources and human resources. Within this guidance, we hear clearly that open science infrastructures should allow us to identify scientific items. And the way to do that most clearly is through the use of unique and persistent identifiers. Within the infrastructure guide that you have here, we have this text that states due attention should be given to these PIDs And we want to use identifiers to make the information more functional over the long term and for the greatest number of users. So we need to consider definition and attribution for many different types of digital objects. We need to make sure that we have ways to effectively share metadata so that we can efficiently use and reuse those materials. And we need to consider proper stewardship of the data and the metadata into the future, and with trusted networks at global, regional, at many different levels, in ways that are interoperable. And I think in order for us to put that into practice, the guidance identifies these 5 areas here. We need to consider the transparency of costs and benefits. We should be able to look at these systems of infrastructures and understand where the resources are coming from and where they're going, understand what's at stake. We need to consider interoperability to enhance reuse, as I've already said. We need to consider cooperative co-creation of these infrastructures to make sure that we're bringing all the open science actors along and benefiting from the multiple perspectives of others in different contexts. We need to work to provide shared attention and benefits rather than setting up infrastructures or systems to compete with each other. Let's work together so that we have a more functional system for more of us. And let's ensure that there's harmonization with open science policy and monitoring, which provide a supportive framework for open science in practice, and also help us identify what is working well and where our key gaps are, where our resources should be directed in future. In terms of looking at how we can turn this into practice, when we consider the creation of scientific knowledge, we often consider these 3 kinds or levels of involvement. One kind is outreach, where you have an expert sharing knowledge in kind of one direction. And that's very different from coming together to create knowledge together using the expertise and perspectives of multiple players. And then separately, there's this idea of co-management, of deciding together about what kinds of knowledge we'll pursue and how we will do so. And I think these same levels can be considered when we're thinking about the governance of open science, or in the context of today's meeting, how we approach decisions about the technologies, infrastructures, and practices that we use for science. Are we just sharing end results? Or are we involving more people in the decision-making process? How can we do so? What does that look like in different contexts? We know that open science is growing, but it is growing unevenly across areas of open science, across disciplines and among countries. The obstacles that remain are linked to those existing inequities. So as we define our ways forward, I think we need to consider who is involved in setting norms and practices. So in order for more people to adopt open science or a certain practice, like a specific persistent identifier, we need to clearly understand what they have to lose. And we need to help each other understand what we have to gain. I would encourage us here to go beyond the moral argument and really examine the financial flows, the structures and practices that we have in science today, as we then work towards open solutions that truly serve all players. So what does this mean for action now? I would argue that collective, collaborative, and coordinated action and investment are needed in order to help us speed up that transition to a truly global, equitable open science. I think part of the answer to how we will do this is that we will do this together, and we can take advantage of this framework that we have embodied in the recommendation. I think that when we talk about collaboration here, we need collaboration among different kinds of knowledge holders across sectors and among countries. And that means South-South collaboration, that means triangular collaboration, ways to facilitate knowledge sharing and to create more international partnerships, including partnerships to co-design the systems that we use for open science. By openness in science, where we're really headed, I think, is integration of the values and principles of open science into research and into the funding schemes, the policy or the national or institutional strategies that we use for science. By going back to these core values and principles that we have in the recommendation, we can advance open science across a range of disciplines, communities, and contexts. So I think let's take advantage of that framework, noting that it also provides flexibility for us to enact open science in a variety of ways that are suited to specific contexts, and that I can account for the fact that open science is continuing to evolve. For us within UNESCO, we've been working with countries and institutions around the world to come together to strengthen open science systems and to learn about open science in various contexts. And as part of this, we've identified 5 key challenges that face open science, one of which is infrastructures and their enabling technologies. I think we'll hear initiatives in today's panel that address these needs, and there are others around the world. So at UNESCO, we have 5 open-ended working groups that are shaped around these major challenges to bring people together and to identify guidance and solutions that can function in a variety of contexts. I already mentioned that the working group members have helped us to prepare a toolkit for those working to put open science into practice. And to give you a taste of what's to come in terms of learning about those actions, I'll mention now that coming up in December, we will be launching the first edition of a new publication, the Open Science Outlook, which looks at the status and trends in open science. It's a first attempt to report on progress and gaps around the world. It's intended to set a global baseline where possible, and to further the development of assessing our global progress under the recommendation. It will serve as a baseline and a supplement to future national reporting, which is going to start in 2025 with an agreed monitoring framework and a national survey tool that will be adopted in early 2024 by the member states. So I do encourage you to join one of these working groups if they're of interest for you. You can always reach out to us to join a group. You can register for a meeting or just email us at openscience@unesco.org. We would love to hear from you about what you're doing to advance open science, what your challenges are, and what's next for you as we work towards open science together. Thank you so much. Thank you so much. Thank you to our hosts. And explore why open science is a global project and what that means.
Okay, sorry. I need to stop the video sharing. And where we are now. Okay, got it. Sorry. Okay, it's me. I'm going to turn on. So yeah, I see a lot of chat, lively discussion, which are good. And please, again, reminder, use our Q&A functions to submit questions. And we will take questions in the end of all of the presentations. So I'm the next presenter as a host. I'm also a presenter. So I'm going to also start sharing my screen. Just give me a second. Okay. I'm going to share my slides. So let me just do it now. Okay. Can you see my slides now? I think so. Perfect. If you have any question, just let me know. So I'm going to thank you, Dr. Tiffany already set us into the context of open science and how important it is in terms of PIDs and open science. So from my presentations, I'm going to quickly share connecting PIDs, how PIDs connections is a route to support open science. So very quickly, I would like to start this lovely but lively picture. It's a picture I found from OpenAir. So it's important to notice that the diversity and sustainability of open science, just like a mushroom or umbrella. So it's in addition to the framework, principles, there are practices included. And in research infrastructure, although sometimes they may not really feel or sensed like under the ground like root, but actually it's a route to support and nourish practices. So as in this lovely picture. So then how's that going? And so to implement open science, there are a lot of actions required, like promotions. You need to promote understanding, you need to develop policy, you need to invest in training, etc. Of course, I think the last but not least point is about investing in infrastructure and services that can also contribute to open science. And research communities work together to build research infrastructure to improve. So in general, research infrastructure are not only facilities, so it's very intuitive. When you think about research infrastructure, you think about equipment or a set of instruments. But in addition to those physical ones, virtual ones are equally important, and persistent identifier or PID or PIDs are one of the critical components of the open science infrastructures. I apologize. I may coughing a little. I may still cough a little bit, so apologize for that. And to enhance reuse, which is a very important dimension of open science about openness. So transparent connections among researchers, organizations, and research outputs data are key to metadata quality, reliability, and interoperability. So with better qualified metadata, of course, it improves reliability because we know who is doing what, where. If that's clear enough, that improves quality, reliability. And with open and standardized services to manage all those relationships and access, etc., that can improve interoperability across different platforms and systems. And ORCID now serves as a hub in this kind of transparent connections between people, place, and things, and interoperability. So very briefly about PID. So for those who may not know what is a PID, so PIDs are globally unique. So they uniquely identify things and people and stuff. So like which entity, which person, which journal, and they are persistent. So they are stable and reliable. They are not reassigned. They are well governed and technically resilient. And they are resolvable by both humans and machines. So they can made into URLs so people can use, and with machines that we have APIs to improve the FAIR principles as just described earlier. And then why is a PID? So it provides clarity, so that disambiguate exactly which to which, what to what, prevents confusion, and it facilitates sharing, reuse, and attribution. So they provide a more accurate picture of activity, so make it easier for researchers to discover and give attribution to authors, organizations, and funders in publication and reporting, and enables automation and interoperability, so it saves money. So back in 2021, there are already empirical studies from Australia and the UK to really go through and investigate the adoption of PIDs really improves automation, which saves time and money. And there are PIDs for different entities. ORCID is PIDs for is a PID for person, and there are PIDs for research organizations like ROR, and for things like from DOI, we will hear more about from Crossref and DataCite, and also now more and more PIDs for like grants or even research projects. So ORCID is a PID. Let me briefly start by also reintroducing ORCID a little bit. So ORCID is an independent non-for-profit organization registered in the US, launched back in 2012. So we just celebrated 10th birthday. And now we are completely sustained by our membership fees with our member organizations. And we are guided by our values and principles. And ORCID is completely, purely community governed by a board of directors. And those directors are elected from and by our member organizations. And ORCID stands for Open Researcher and Contributor Identifier, provide three main services. The first is ORCID ID. So it's an ID for people or people who contribute to research. So ORCID ID is not for organization. ORCID ID is only for people, but we work with different organizational IDs like ROR. And when we say, and all researchers, all people are welcome to register for ORCID ID. And when we say members, it means organizations. Our members are organizations, not researchers. And ORCID provides what we call APIs, kind of application programming interfaces. Basically, it's a services and it's a support for organizations so that they can adopt those APIs to their systems. And those organizations can exchange information in the research workflow across platforms, as I just described for interoperability. And ORCID is a place to store and share those different connections between IDs, research activities, and affiliations. So this is ORCID record, if you haven't seen this before. So there are different parts of research information. And there are two sections now can only be added by member organizations. One is peer review, the other is research resources, and rest. And there are also like other IDs can only be added by member organizations as well. But the most of the parts can still maintained by researchers themselves. And to recap, so ORCID associates researchers with institutions and research outputs through links to different PIDs. So we work with PIDs for organizations, we work with PIDs for data outputs, research outputs, and also PIDs for funding or grants. So, and also now it's through the community support. Now we reach quite a good adoption globally. We have almost users everywhere, which is quite impressive. And we have member organizations now across in 57 countries, and there are more than 1,000 member organizations, and there are nearly 5,000 systems that integrate, adopt ORCID. And to quickly also go through this, so ORCID member community, including direct members and ORCID Consortia. So all organizations are welcome to join ORCID directly as a direct member. And we also offer ORCID Consortia model to nonprofit organizations. So ORCID Consortia is an ORCID consortium, you should use singular. It's a group of at least 5 nonprofit organizations that work together to adopt ORCID into more national context and national resources, and they form communities of practices that can, fit more local needs. So in terms of the APAC situation, we have ORCID Consortia in Australia, in New Zealand, in Japan, and in Taiwan. And from the following section, I'm going to go to really about the implementations, and let's recap why PIDs is a part of open science. So the vision, and we want open and standardized services to build transparent connections among people, place, and things to enhance quality, reliability, and interoperability, and how to achieve that. So disambiguate your researchers with ORCID and the relating information at the ORCID records, and use ORCID and different persistent identifiers and their respective APIs to obtain authoritative metadata about paper place and outputs, so that your system can connect multiple systems and acquire more qualified information. So implementations. Now, for an organization to adopt ORCID, the 5 steps are the best practices. The first is to researchers, of course, have an ORCID ID first, and they connect their ORCID IDs in any research workflow, like in publishing workflow or in research management workflow. And for organizations to display those IDs, and organizations can use API to collect information, read data from ORCID records, and also add validated information, write data back, and eventually to ensure your system synchronized with ORCID. So always stay up to date. So there are some case studies I want to share, and I will use each kind of workflow as an example. The first is from the Research Institute workflow. So it's a university in Colombia. It's UNIMINUTL. So we have a blog post which you can read more details. But basically, this research institute commits to open science, and it states that they support those following adoptions, including local profiles in Colombia and identifiers and different tools and platforms in the overall research workflow. And this is the example. So research institutes can add validated information by using ORCID's API from their system to ORCID. So when an ORCID member like this updates ORCID record, the source name will be them. So this provides we call trust markers, because it's from organizations adding authoritative data at first hand, and those Connections, trust markers can be used to help in further decision-making. And this is an example for the university to add employment information, as you can see here. And next is from publisher side. So for publisher member organizations, they can add peer review, whether it's open or still double-blind, single-blind, or publications. Like this is the example for peer review. So it's from 1,000 and plus. So again, this kind of connections from publishers directly to the authors or reviewers ORCID record. We call it trust markers. And the third is from funding workflow. So funders can add validated information like funding information or peer review. So there's also a peer review in the funding workflow. So this is the example from American Heart Association. They add the funding record to their grantee, yeah, that's the right word, grantees ORCID records. And this is from UKR in the UK. They add a real peer review for funding application to their grantees ORCID records. So organizations, they reuse PIDs and metadata to improve workflows. As you can see here, this is kind of the major workflow systems that everyone will encounter in the research workflow, from publisher into different institutional system, funder systems, or discovery profile system. So let's go through the kind of validated information trust markers cases I just described. So that's from researchers. So for a researcher working at a university, when he or she signs into the CRIS research management system in their universities, the system can read publication information added by publishers. So when the researcher signs into the system, publishers added validated publication or review information into the researcher's ORCID record. So the institutional system can read information back and pre-fill in their local system. And for discovery systems, they can use DOI metadata that again added by DOI providers, infrastructure providers, or by publishers in the ORCID records, so they can track authoritative copies of publication. So, and for funders, they can add funding that can be reused by different parts of the stakeholder or different part of workflow. And they can also use information added back by other systems when they are doing their internal funding workflow. This is why we mentioned about the trust marker use cases. And this is something we would very much like to work with the community. And here, just quickly mention, ORCID now has a CSP program. We had a certified service provider program. We work with products and services to ensure they support ORCID's API and they meet our best practices. So if your organization is interested in using ORCID, you are welcome to take a look at those systems so you can know if you already use these systems, you can immediately turn on the ORCID functions and you can start to work with us. And there are a few already support ORCID but not yet certified, like Pure. We are working with them. So all the information can be found in our website. And also, I want to highlight the part about policy. So as in Dr. Tiffany's presentation, we know it's kind of, open science cannot be done without the proper framework policy support. And now through the community efforts, we kind of understand globally, founders start to also implement PID policies to foster open science in different components, open access, open scientific workflow, or data management. You can visit our webpage for more details. And that's a bit different topic, but I think it's equally important to raise here in today's webinar, because now, again, open science is also about to promote the equitable access to the global community. So ORCID offers now a program called Global Participation Program. We want to ensure the equal participation of scientific procedures from less privileged institutions and countries. And we have two parts. One is membership equity program. The other is global participation fund. So the membership equity program is a program we want to work with lower middle income countries to offer them a chance they can start ORCID consortia with less cost and less members. We can start from 3 and with less membership fees to ensure the equity. And the other is called Global Participation Fund. So there are two funds. One is for community and development outreach. So to apply the fund to support local community development. The other is about the technical integration fund to apply to ensure there are more open systems that can benefit the community, especially in more underrepresented regions. And as a start, please. So if you are a researcher or if you are like a data curator, not a researcher, but you know involved in the research workflow, start to register for your ORCID ID and fill in the application form to let us know what you are interested in terms of adopting ORCID, so we can send you more information. And we offer the sandbox. It's a free testing registry. You can try out all the APIs and please fill in the sandbox application form. So yes, let's commit together by open science. And PIDs alone do not provide much value. The value really comes from embedding PIDs in different systems, connecting to them, visualizing them, leverage those relationships. So thank you, and please feel free to reach out to us anytime. I'm going to stop sharing and move to our next speaker is Martin. So okay, great.
Hi. So let me share my screen and show my slide. And yeah, thank you very much for your last slide, Estelle. It leads perfectly into what I wanted to talk about. Oh, sorry, I need to get up to the bottom, so I start at the top rather than the end. Right. So yeah, I'm going to talk about building relationships, which is it follows on exactly from where Estelle's presentation left off. So I work with Crossref, and so this is our mission. It's to make research outputs easy to find, cite, link, assess, and reuse. And we believe this is fundamental to open science as well. We're a not-for-profit membership organization. Our community is global. It's across the world. We were established around 20 years ago by a few very large publishers, but now our membership is mostly consisted of organizations that wouldn't necessarily identify themselves as publishers, and truly global across every continent, and very diverse. So yeah, what I would like to talk about today is some specific areas about depositing metadata and delivering metadata, and how metadata connects together. So this is a vision that we have of research, which we call the research nexus. And in the center here are various outputs. So this includes the journal articles, books, preprints, and those kind of things that our members register DOIs for. So we are a DOI registration agency, typically for journals, books, and that kind of those kind of outputs. But we want to look beyond that, and also in the middle here you'll see things like data, software, theses, blogs, conference materials. There's also organizations and people in here, and we want a lot of those entities have digital identifiers. And we want to connect those up and describe how they interact, how they connect with each other. And around the side, you'll see various actions that can happen. So there may be an ORCID, an author who's authored a research article. There may be a project that's been funded by a funder and a grant. Those also have identifiers. There's comments, reviews, and what have you. So various kinds of relationships between outputs. And I'm just going to start by focusing in on one type of relationship, which is references. And then I'm going to look more generally at relationships and how we're delivering those in a new way. So on the left here, you have Isaac Newton, and he was, by all accounts, not a particularly, well, a brilliant scientist, but quite an arrogant guy as well. And he said the famous quote, you know, if I have seen further, it is by standing on the shoulders of giants. And I very much hope that he was referencing who those giants were, what work they'd done, and how that contributed to what he was working on. And so, you know, references provide context and acknowledgement. They point to the shoulders of the giants on whom your work is standing. Notice this isn't about, you know, counting citations and you know, who's the best and how many citations have I got. This is about putting research into context. If you know how research connects, you can follow a thread of thought through various different publications, see how it's supported or contradicted, and so on. Another really important point from the Crossref point of view is that we don't have the capacity to go out looking for references. We depend very much on our members to deposit the reference metadata. So if you are a Crossref member and you don't deposit references, then I would encourage you to do so, because there are many benefits in terms of open science. Also, you know, reciprocal benefits, because we have around 17,000 members. If you're depositing your metadata, you're helping them to discover links to their works, and you've got 16,999 others who are seeking to build links to your works as well, and to provide further information and context to your outputs. So just briefly, practically, there are various ways that the reference metadata can be deposited, and I think it's important that we have a range of tools. I talked earlier about the diversity of our membership, and we have a diversity of tools. So some are, you know, proficient with XML, and if you use XML to deposit, then adding references is another part of the XML schema. If that doesn't mean anything to you, that's fine, there are alternatives. So if you're using OJS, Open Journal Systems, this is a very popular open source editorial system, then there's a plugin specifically for depositing references. There are some of our members that rely on the web deposit form, which is a user interface on our website. If you're doing that, then depositing references is not integrated with that, but there's another page called Simple Text Query, where you can deposit references just as text. You know, you don't need to pass them and say this is the author, this is the title, and so on. You don't need to add the DOI. We will look up the DOIs if they exist and add them to the references, and you can deposit directly from there. And we're also working on a new deposit tool as well, which will be more flexible, more adapted to our schema. We had our kind of annual live event yesterday, and one of my colleagues was talking about that. And yeah, look out for the new deposit tool if you are a member and you're using the web deposit form currently. So what we know so far is that 52% of journal articles have references. It's a great start. It could be higher. What we also know is that these are concentrated actually within a minority of our members, and there are many members who are not yet depositing references. And if you're among that number, we would love to hear why, whether there are specific difficulties with depositing references, and if there's something we can do to assist. So cited by is a way to retrieve information about references that have been deposited. It's to retrieve citations to your works. So maybe another member deposits a work which has a reference. There may be citation matching, at which point we add the DOI to the reference, and that's delivered via an API. But if your work is cited, then we also add the we associate that citation with your work. We update logs, we update citation counts, and then we allow members to retrieve citations through cited by. And again, there are several ways to retrieve cited by results. There's an admin tool, which is a very basic user interface. and then various APIs. I'm not going to go through those in detail, and I'll talk about one further way shortly that you will be able to access these results before. Now, it used to be, I put this at the bottom of this slide because it used to be that we required reference deposit before you're able to retrieve cited by results. That's not a requirement anymore. So if you're interested in seeing who's been citing your works and you don't yet deposit references, you can do that. I would strongly recommend that you do deposit references, however, because otherwise, when you retrieve those works and say you display them on your website, then you won't have the links back to your own your own citations, kind of self citations, which are important also to see connections within your own journals and outputs. So yeah, just briefly again to go through the benefits of depositing references. It's about linking to and from your own works. It's about supporting research evaluation processes. And then the main message that I think I would want to get across to you is that it's about putting research in context and helping people to understand more about where research sits within the scholarly outputs. So yeah, coming back to this diagram, of course, references is just one part of this, from from journal articles mainly to journal articles. That's where the interest lies, but there's a whole broader ecosystem of identifiers and scholarly items that are out there, and we really believe that part of open science and fulfilling open science is to complete this research nexus. And I think we quote, I don't know where this number comes from, but about 60% of this is possible at the moment. What it means basically is there's much more that we can do and that we can work with the community to fulfill the this. But I want to talk to you about one important part of the puzzle that we're working on at the moment, and that's outputting these. So I'm just showing you this is JSON output from our APIs. If you're not familiar with this, it doesn't matter if you can't read it. It also doesn't matter. I just want you to have a look at maybe the shape of these three things, and you can see that they're quite different. And if you can read what's on the slide, then you'll see also the field names that are in blue are quite different. And these are three different outputs of relationships. So on the left here, we have this is event data, where we look to collect relationships from Crossref DOIs to other items on the internet. So that's Wikipedia, it's hypothesis annotations, we do look at Reddit and some blog posts and other things. In the middle here is the reference lists that I was just referring to. These have a very different format. And then it's also possible to put, for example, supplementary data sets and what have you. They can go in reference lists, but they can also go in relationship metadata, and that's here. So we have these relationships available, but if you want to look at the whole picture, you need to go to three different parts of our outputs and combine them together. And it's, at the moment, we don't make it very easy to do, I think, to some extent. So what we would like to do and what we've been working on is combining these together. Can we combine them together? And in doing so, actually it provides some significant efficiencies for us internally, as well as for our users looking at the data externally. And this essentially comes from saying that DOIs are what we do on a day-to-day basis. However, we're not the center of the universe, and other identifiers are just as important. And taking that a step further, can we look at these relationships from different perspectives? So we've been working on a relationships endpoint to our API, combining all of these and delivering them in one place. And I'm pleased to say that this now works. It's just up and running. And you can make the kind of query that's at the top here. So I've tried to color code it. So if you're not familiar with API queries, you can try and understand what's going on. So firstly, we have a URL, this part in orange here, which is where this is the relationships endpoint. Sorry. Yeah. So this is where we're looking for the data, and then you can filter the data down like you would in a search in a search interface. So you can say we want things that are of type work rather than people or organizations. We want to look at data sets. Let's have a look at data citations, for example. And then we can put some time filters. We're just going to look at 1 day's worth of data here. And then this is the output that you get. It's intended to be machine readable. But you can see three main parts here. You have a subject. So this is where the relationship comes from. And this is a DataCite DOI. This is not something that Crossref holds in our collection. This is from DataCite. The object, which is the other end of the relationship, this is a Crossref DOI. So this is some kind of data citation. And then there's a relationship type, which is supplement to. So this is one way that we're connecting things from outside of Crossref to items within Crossref, and any data citations that we have, and we work very closely with DataCite, who very generously share their data with us. Any data citations that they have and that we have are available together through this endpoint. And we also deliver, DataCite also have their own endpoints for showing the same kind of data. So you can look at it from either side. If you want to find out more about this, I will share the slides afterwards. And I did a short presentation yesterday in our live event, which gives some more background and examples. But I just want to give you one example of looking at things from a different point of view. So here you'll see a similar kind of output, similar kind of query. We look at relationships, and here we want the object ID to be this DOI. And this DOI is not a journal article, it's not a book, it's not a preprint, this is actually a funder. And so what we're looking at here is which research outputs has this funder supported. And if we look at the subject items here, we can see, there's a number of, there's actually thousands of results. I've just shown a few for clarity, but, you can look at the data from the funder perspective, and that's another group of organizations that we're very keen to support and work with. So just to maybe put forward some challenges and opportunities, in order to do this, in order to build a research nexus, in order to support open science, we need high quality metadata. It's on our side to build a diverse range of tools and collaborate with organizations to make those tools available. We work with our community to make sure that once those tools are available, we get as full metadata as possible, and help people to see the value of depositing high quality metadata. And part of that is the broader use of identifiers as well. And we work closely with all the the other identifier registration agencies to do that as well. I just wanted to mention very quickly another couple of items that I think are related to open science. We have a global network of ambassadors. This is an amazing group of people taken from our membership, who give us feedback on ideas. They tell us the struggles that they have. They help to get the message out about Crossref. They're really amazing group of people, and I'm sure my colleague Obanda, who's on the call, would love to hear from you if you're interested in joining that program. And also the principles of open scholarly infrastructure. These are some of our guiding principles that are also available to other organizations to follow, that help us to work in an open way and a sustainable way, and to support open science from the point of view of scholarly infrastructure. So yeah, thank you very much for your attention.
I'm here. Okay, great. I'm sorry, that's my voice. Okay, I'm going to quickly invite Xiaoli. I'm aware time is approaching, so thank you everyone for those lively discussion already in the chat, so please. And Xiaoli, please.
Oh, hi. Yeah, let me share my screen really quickly. Yes, so I'm also very aware of time, so I try to go through my presentation quickly so we have some time to answer questions. So hello everybody, I'm Xiaoli, and I'm a project lead at DataCite. And yeah, so I'm really happy to be at this Better Together webinar series for the APAC community. I'm based in Edinburgh in the UK, but I just came back from a trip in Beijing where DataCite co-organized a workshop on Open Science Identifier with our local host at the Common Science and Technology Resource Identifier team at the Computer Network and Internet Center at the Chinese Academy of Sciences. So on that workshop, our colleague, Professor Wu at one of the DataCite member organization, the China Geological Archives, he shared an interesting use case for the DataCite DOIs at their institute. And they use this as a marker for credit and recognition because in their experience, voluntary contribution of geological data are rare and generally unrecognized because they are not only being collected and used by researchers, but also by developing like project companies and commercial entities. So by implementing DOI registrations, the data sets become permanently and openly accessible, which turn out to be a great incentive for the community to commit to data sharing. So when Estelle put together this theme for this webinar, this is immediately came to my mind, and I think that it's a great story for PID promoting open science. And just one very brief word about DataCite. DataCite is a global nonprofit membership organization working with over 2,800 repositories in the world to provide the DOIs for research outputs and resources. And the DataCite global community share a common interest to ensure that research outputs and resources are openly available and connected so that they're reused and can advance knowledge across and between disciplines now in the future. And we do this by maintaining a metadata schema and operating the infrastructure that supports adoption based on it. We participate in the global open science and scholarly communication work through numerous collaborated projects, and we continuously engage on and offline within and beyond our community to develop best practices, deliver trainings, and determine the next step forward in terms of research data management and open science in general. And that is the three aspects around which I built this presentation on how building connections is key method for PIDs to advance open science. There's a connection in metadata, connection across collaborative initiatives, and the connection through engagement in the community, starting with metadata. So what is connection metadata? DataCite metadata schema accommodate insertion of links to other identifiers, be it DataCite DOIs or identifiers from other PID systems like those from ORCID or Crossref. So metadata, a connection metadata is metadata that represent relationships or connections between different entities. For example, you could have connection metadata for a paper citing a DataCite, a person authoring a paper, a person's affiliation with an institution funding a research project that generate many outputs, or DataCite being generated by a piece of software relationships like that. So this metadata helps facilitate interoperability between persistent identifiers and PID systems and open research infrastructure in general. So among these, obviously, formal research publications are well established and have been identified with Crossref DOIs historically since 2 decades. However, to encourage open sharing and connecting different types of scholarly resources is necessary to first surface those that are not research papers. And this is where DataCite DOIs come in. DataCite DOIs are suitable for a wide range of research outputs, including research datasets and collections, associated workflows, software, images, and models, and as well as great literatures such as thesis, dissertation reports, unpublished conference papers, newsletters, preprint journal articles, etc. And these are a very vital part of the scientific processes and like traditionally kind of buried in the process, and they don't get to be discovered or reused. So once these entities are identified with DOIs and the metadata is created and submitted to DataCite, they're exposed through the DataCite infrastructure, like the Commons DataCite Commons, the metadata discovery portal is a website, and the various open APIs for querying or harvest. So on the left is a screenshot of the search bar of DataCite Commons, where metadata of resources that are linked in any way to DataCite DOIs can be searched. And resources and relations can be aggregated on the work, people, repository, and organization level. On the right is a visual representation of the PID graph, so a network of linked PIDified entities exposed to the open APIs. So this recent graph generated using the DataCite GraphQL API and R gives you a glimpse of the most prominent features of the DataCite metadata corpus, with like around 30 million datasets in the center and related software, funder, institute, researcher, and publications represented, and how they are connected together. So moving on to the next section, the connection across initiatives. DataCite participate in a wide range of global and collaborative scientific projects. So this on this slide is like a fraction of the projects that we are currently working on, actively lead and contributing to. So we work with colleagues across domains and national borders to leverage the open scholarly infrastructure, that is to say PIDs and metadata, to create anchors for research entities, to surface insights from the aggregated metadata, to support impact measurement through open access of these metadata, and thus complete the virtuous cycle of open and fair research. So when you build the incentives through these the added value from the metadata, I just briefly introduce these projects. Make Data Count initiatives works to make data citation a priority by incorporating data metrics into institutional and funder evaluation processes, as well as research assessment. This will be achieved through the creation of a central aggregated of data citation form from various sources, and a dashboard for visualizing data citation based on different dimensions. The Fair Impact projects aims to realize an EOSC of the European Open Science Cloud of fair data and services by supporting the implementation of fair enabling practices, tools, and services across scientific communities at European, national, and institutional level. The Fair Island project translates fair and care data principles into practice for scientific field stations through the development of place-based data policies and the critical research infrastructure centered on machine actionable data management plans. And finally, the FAIR Workflows projects aim to build and implement an exemplar, fair, and open research workflow based on the reality of an entire research lifecycle. Through the project, we are producing a series of guides for funders, researchers, and research tools and platform providers who want to integrate open infrastructure to bolster their service. I am the lead of the Implementing Fair Workflow project, so it's a shameless plug for our project. The subtitle is a proof of concept study in the field of consciousness, because we work at DataCite with a team of researchers at the Max Planck Institute for Empirical Aesthetics, so our neuroscience researchers, to monitor the entire PhD project over 3 years, to design the research process and execute it and document it, and to reflect on all the stages and points where fair and open practices can be implemented. This project is funded by the Templeton World Charity Foundation, and we have a slate of great project partners who work with that. They provide tools and platforms to support these workflows. On the right are the key components of the project. I'll not go into it as we have very limited time. We kind of base our project on this 8-stage model of entire research project lifecycle, and building integrations across tools, and formulating research practice with a research team. And this is an outline made by our research team to show the comparison between traditional workflow and what normally a fair publication would look like, and in the fair workflow, what we are doing. So in the traditional workflow, only the research paper kind of surface once the entire project is accomplished, and but in a fair research project, you will have not only the paper, but everything that is associated in the paper. However, the paper only shows like the main experiment, which usually are propped up by a series of smaller pilot experiments. And that's what we surface in the fair workflow project. We surface everything, and you see the true value of the research projects. And finally, connections through engagement. I cannot emphasize this enough. Creating connections through community building and empowering is the heart of promoting adoption of open scholarly infrastructure and open science practices. That's why we have, as I said, we have like 280 members across 51 countries in the world, and we have collectively implemented over 56 million DOIs identifying the scholarly resources, and we're proud of this achievement. And in the DataCite community, this community consists of these 4 main categories of stakeholders, and each groups are subject to playing a number of active roles in the community. You can see the members are the only ones that's creating the DOIs actively, and we have a slate of stakeholders that support all of the adjacent policymaking, promotion, adoption, discovery, enable activities. So we do connect to people both online and offline, where there's our community. So we have this year carried out 2 editions of the DataCite Connect in-person events in Gothenburg and in Buenos Aires. I just want to, those are both successful events. I want to mention that the PID Fest is coming, that is co-organized by the ARDC Australian Research Data Commons and the National Library of Czech Technology in Czech Republic. And we are planning to also host the DataCite Connect event next year, co-locating with the PID Fest. So yes, that's an advertisement for an upcoming event. Is my presentation. Thank you very much, and happy to answer questions if we have time.
Yeah, thank you, Charlie. Again, thank you all the speakers. I invite you to turn on your camera. I know we have a few minutes left. I thank you everyone to bear with the technical issues in the beginning of the webinar, but I'm so happy that we be able to resolve that. Yeah, so I think we in the last of couple minutes. So again, please submit your questions now, because if we have no time, we will definitely include it in the follow-up email, or you are welcome to reach out to us. And I would like to again use a mini poll to conclude our webinars today. Aside from discussions. So let me just again to launch the polls. Hope all is okay. I feel like I'm a bit okay. It should be okay now. Yes. Can everybody see the poll now? Yes, perfect. Yeah. So please take I'll wait for 1 minute to let everyone to share your feedback. And I think this is really kind of, if to my knowledge, kind of the formal first webinar from infrastructural PID providers, Crossref, DataCite, and ORCID, along with the UNESCO, to really highlight the importance of PIDs and open research infrastructure, and how those should go in hand. And I really hope this could be a start again to connect. I think connections are the key words today. Great. Let me just wait another 30 seconds. I think almost everyone is going to complete the poll. And I'm happy to see that. Yeah, I'm going to share the results later on. And if you have any questions, please feel free to reach out each of us, or 2 of us if you have multiple questions, to different organizations. Okay, I'm going to stop polling now. Let's see the result. Great. So I think it's good to know that most of the participants, somehow your organizations are affiliated with each of the following organizations. And again, we welcome you to reach out to us to see how we can work together with your organizations. And yes, I'm happy at least it's quite positive that people feel it's it gives them a bit light on PIDs and open science, which exactly I think that's the purpose of this webinar. So before we close, I would like to invite again from Dr. Tiffany to say a few words as kind of take-home message before we ending this. Oh, I haven't. Did I share the polling results? Okay, I think I shared now. Great. Just for your reference. And yeah, I will invite each of the speaker to briefly comment, probably another 3 minutes. So please.
Sure. So thank you, Estelle, and thank you to everyone who spoke today and for all this activity in the chat as well. I think for me, a takeaway here is that there has been so much advancement in terms of the technical tools that we have. And let's make sure that those are within reach of everyone. I think that even for those institutions which already have an affiliation with something like Crossref or ORCID, we still have a lot of work to do to help research teams feel that they can take advantage of these tools. And we also have work to do as a global community to make sure that we're equitably sharing the costs that it takes to operate these infrastructures, even though the cost, let's say per Crossref DOI or something is quite minimal as a single unit if you're in a certain context. Thinking of putting, let's say, the body of African literature in the DOI system or the body of research for a whole country, it can be quite daunting. And I encourage us to continue to work together to reap the benefits of these shared infrastructures and making sure that by adopting these new systems, we're adopting them for all science actors around the world. Thank you.
Yeah, thank you. I'm good from my side. I just want to say thank you and let's connect together. So Martin, probably just one last sentence as a concluding remark.
Yeah, I think what Tiffany said is really important. I think the technical tools are the easy part. It's building community, building building awareness, and of course the money as well. And yesterday one of my colleagues said we have a program for providing access to low-income countries. The fact that we need to have this program means that something is wrong with the model of how we're funding something, and we're starting a project to look at that and see how we can make everything more equitable. But there are just so many facets from this, from the technical, the community, the policy, the funding. But we're working together to address these problems.
And Shelley, and thank you for wrapping up quickly.
Yes, very, very quickly. Agree with everything that's said. And DataCite also have a similar program. It's a global access program that looking at helping less privileged potential members to join this community, to engage with them. So everything can be found on the website, and welcome to connect with us.
Yeah, thank you, everyone. I think it's okay. We just running on the 3 minutes. Again, thank you, everyone. And the recordings and the slides will be shared afterwards. We will send up a follow-up email in the next week or so. So yes, thank you, everyone. I'm going to close this webinar. And again, happy to meet with you here. And good day, good night, good evening to all of us. So thank you and chat soon. I'm going to close this webinar. Bye-bye, everyone. Bye-bye.
Bye.